So through this video, we are discussing a topic about waves, and today we are going to discuss something related to AS levels, which is frequency of sound waves by a cathode ray oscilloscope. So we will see how we can use a cathode ray oscilloscope to determine the frequency of a sound wave. Now, first is what is a cathode ray oscilloscope? What does it do? So if you look at this diagram, there is a signal generator which is sending the signal to a loudspeaker. The loudspeaker is sending a signal to the microphone, and the microphone is connected to a cathode ray oscilloscope, which is also known as CRO. And what this cathode ray oscilloscope is doing, that it is showing a graph. It is showing the signal wave as a trace, right? So this is the trace of the signal which was received by the CRO, and this trace depends on the Y plate sensitivity. Y plate sensitivity means what is the scale on the Y axis, right? And apart from that, there is a time based setting, right? Time based setting is basically a scale for the X axis. So we will learn now how do we use the Y plate sensitivity and the time based setting to find out the frequency of. Now you see the trace is given over here, and we are given what is 1 centimeter, right? So there is a scale on this. If we notice that 1, 2, 3, 4, and 5, 5 small boxes represent 1 centimeter, right? On the x axis, because time is plotted on the x axis here, right? Now Now on the y-axis, same thing. On the y-axis also, 5 small boxes represent 1 centimeter. What does this mean? One small box is zero point 0.2 centimeters, right? Now what we have to find, see, this is an example question given to us. Time-based setting for the CRO is 2 ms. Ms is millisecond per centimeter, meaning 1 centimeter corresponds to 2 milliseconds, right? And we know 1 centimeter is how much? 5 small boxes correspond to 1 sorry 2 milliseconds, right? Now one small box represents 2 upon 5 milliseconds, which is 0.4 milliseconds, right? Now what is given to us? We have to find the time period. So to detect the time period, what do? We take the distance between consecutive crests or consecutive troughs, and then we find the time period using the scale on the time based setting, using the scale on the trace, right? We know one small box represents zero point 0.4 milliseconds. So if I look here, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So now my time period is what? 15 small boxes. That means 5 small boxes was 1 centimeter. Now time period. So what I will do, let me write with a different color here. Time period is equal to 3 centimeters, because 15 small boxes, right? And 3 centimeter is 3 into 2 millisecond, which becomes 6 milliseconds. So basically, my time period over here is 6 milliseconds. Now, what is the frequency? They're asking the frequency of this. Frequency is 1 upon the time period is equal to 1 upon 6 milliseconds. That is 1 upon 6 into 10 raised to minus 3 seconds. That becomes 1000 by 6, right? And what is the unit? Per second. This unit is also called as hertz. So basically the frequency becomes 133.33 hertz. Yes, 1000 by 6, which is 100 and not 133, it will be 166.67 hertz, right? So what we did here, to find out the time period, we calculated the time period by using the scale on the time base setting of the trace. From that we found out the time period, and 1 by time period is the frequency. So basically the distances between the troughs or crests helps us in calculating this. So what I want us to do is, we will now look at a question. This is a question in front of us, some data is given to us, and we find out the time period and frequency in this case. You can find out the answer and write your answers in the comments below. I hope this video was helpful. If you want to know more such stuff, please follow us on Facebook on this account. Instagram account is also given, and if you want to attend live classes, you can call at the number given. Thank you so much. Have a wonderful day.